This video is another part in our series on database transactions. So in part one, we defined, what we meant by a transaction. So some sequence of steps that are meant to sort of work as an all or nothing unit. And then in part two, we looked at some of the problems that can occur if two concurrent transactions are not properly isolated. And now we want to look at a mechanism of isolation known as locking. So we have transactions and we want to prevent them from interfering. We want to keep them properly isolated so that they can pass the acid test, or at least the eye of the acid test. And so we introduce this idea of locking, that you put a lock on the data and you say, like, this data is mine and you can't touch it. So that if somebody else comes along and wants simultaneously to work with data, um, they know that you have a hold on that data. But if they want other data, they're fine to go ahead, provided that it is unlocked. So so we have the first transaction will come along and put a lock on the data, and then the second transaction will come along and it will have to, when it announces that it wants that data, it will have to sort of see the lock and sort of look into the compatibility of the two transactions. All right. Now we have two basic, we'll call them read and write. If we're just reading data, we're looking at it, or in database language, we're selecting it, and we're not really changing the data, we're just looking at it. And if two transactions just want to read the same data, that's not a problem. And so, uh, but it is a problem if somebody else wants to come along and write the data. So, if you're the first transaction in and all you want to do is read it, you will put a lock on the data, but you will put a shared lock on the data. So you're just announcing that I'm my transaction involves this data, but I'm just reading it. And so I'm willing to share if the other transaction is. So then the second transaction will come along, and if it also wants to just read the data, if it also wants to have like a shared lock, then they can indeed share. So if both parties want to share, then we can share. If the first party wants to share, but the second party wants to be what we call exclusive, they want to read and write, they want to select and update, then they're not willing to share, so they will have to wait. So the first transaction came along and set the shared lock. I'm just going to read this data and I am willing to let other people read it as well. But the second transaction comes along and says, I want to do more than just read the data. I want to update the data. And so therefore I want an exclusive lock. And when I put in my request for an exclusive lock on some data that already has a shared lock, then I am told to wait. So, and a shared lock won't work with an exclusive lock. And in this scenario, the scenario just described, the shared was first. Transaction one requested the share. If transaction one wants the exclusive lock, so transaction one this time is going to select and update, look at data, and then change it. Then it requests an exclusive lock. And then transaction two comes along and says, I'd just like to look at this data, but it sees the exclusive lock. So it knows that transaction one, which has already begun, is going to write data, is going to update that data. And therefore it knows that it must wait to that transaction is done, that the database is returned to a consistent state, and then it can read that data and know that it's proper data in a proper state. So the access won't, the second party is requesting a shared access, but the first party said, I am not willing to share. And so the second transaction is put in a waiting state. So it didn't matter share and share, they shared. But if it was share then exclusive or exclusive then share, then they do not share. And of course, exclusive is definitely not going to be simultaneously to share to be concurrent. We're going to sort of force a complete serialization. Do transaction one, finish it, then and only then start transaction two. So both transactions are at least think that they will read and update the data, and so transaction one gets there first and requested the exclusive lock. I'm going to change the data. Then transaction two comes along, makes the request for the data, sees that it's already got an exclusive lock, and must go into a waiting state and wait till transaction one is complete. And then, and only then, can it get access to the data to start its transaction. Okay. So only shared locks can be shared. Every other combination, only share and share will share. Uh, any any time there's an exclusive lock involved, the second transaction is going to have to wait, and this is going to hopefully prevent our problems. So there's a little more nuance. So we'll talk about a little bit more nuance, but exclusive locks need to, as they say, they want to be exclusive. They don't want to share. They're not going to share. They'd rather wait. Okay. So only when the first transaction is done, and it may be committed and may be rolled back, but only after the system is returned to the consistent state will the second transaction come in. Okay. Now we have this concept of uh, shared lock, exclusive lock, different levels of locking. What some database systems will allow is for you to sort of change the kind of lock you want. So you might come in sort of reading some data, and then maybe under some condition you will update it. So then in the beginning, you're assuming I'm only going to read, so you request the shared lock, but then given the condition of the data, you assume that now you want to change the data, you want to do some updating, and so you must sort of change your lock. You must upgrade your lock. I need the more expansive lock. I need the excluded lock, and so that it would be known as upgrading the lock. The other scenario possible is that you come in sort of assuming that you're going to read and update the data. So you request the exclusive lock, and then you do the reading and you look at the condition. You say, oh, never mind, I'm not going to change this data. And then you can downgrade the lock. So there can still be some problems, so we have to add in some additional features to our locking system. But here is one of when we looked at the possible things that could go wrong. Here was one of our scenarios of in transaction 9, T9, we are moving $100, I think, from one balance to another balance. And in transaction 10, we are paying interest to those accounts. And so if we get caught in between, now we can say transaction 9 is going to read the balance and then add the 100 and write it. So I'm sort of done with that data, the balance X data. And then so transaction 10 can come in and say, okay, X is available. Let's, read and write, pay the interest, and balance Y is available. Let's read and write the and pay the interest. And then transaction 9 comes around and is subtracting the $100. And so, but we know that's a problem, that there was an extra $100 in play when the interest was calculated. And so once the bank paid out extra interest, which the bank does not want to do. So we know that this is no good. Now it seems to obey like the simplest kind of locking, that transaction 9 locked and then released, and transaction 10 locked and released and locked and released, balance X, then balance Y, and then 9 locked and released, balance 10. So it seems like all good and fine, except we know that it's not, that we paid too much interest. But in terms of locking, it seems fine. So we change our notion of locking and within a transaction, and we say that there are two phases of locking. So you sort of request locks, you're granted locks, you release locks, but now within a transaction, within what we call two-phase locking, you can only sort of lock, 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 release, release, release. So you you only you request all the locks that you want. Sort of this we call a growing phase. We're locking more and more things up, and then when we've sort of reached the stage where we've done what we needed to do, then we can start releasing. So now that problem we just talked about in sort of paying too much interest is uh, would be prevented by two-phase locking. So uh, transaction 9 would lock balance X, would request the exclusive lock, and then transaction 10 would come along. But as in two-phase locking, the hold on balance X would not be released because transaction 9 still wants to do something to balance Y. And so it is not done all its locking. So this problem of paying the extra interest would be prevented by two-phase locking because 10 could not get started because 9 had not done all of the locking it intended to do. So we've got to do lock, 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 build up in our locks, and then only when we reach the stage where we can start releasing the locks, release locks. So it's all request locks and grant locks and then release them. No, it's not request, release, request, release. No back and forth. It's all request, 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 release, release, release. So we talk about the two phase, the growing phase. I ask for more and more locks, and the shrinking phase. I give up. I release more and more of my locks, and this prevents some of the. It helps to isolate our transactions and make sure that they don't interfere. That we are indeed in consistent states, and that we're waiting for something to be done so that we remain in a consistent state. Um, if you have a system that allows that sort of upgrading or downgrading, remember upgrading was I had requested the shared lock and then changed my mind and wanted to move up to exclusive, or downgrading, I have the exclusive and I'm going to go down to the shared lock idea. Then if you have two phase, then upgrading is something that you would do in the growing phase. and downgrading would be do something you do in the shrinking phase. So uh, sort of upgrading is part of growing, and downgrading is part of shrinking. If you're allowing that kind of thing. So here we have some of our previously talked about scenarios. So here, transaction two sort of got in there ahead of time, and they were adding $100 to the account. And transaction one is taking money out of the account. And but so they're both reading and writing. And transaction two got in there first, and it puts the hold on balance X. And then so transaction one got in there later, and it must wait. And so we see the wait, wait, wait. I requested the lock where I'm going to change balance X, and I must wait until transaction two has finished. So I'm forcing the serialization. The locking has forced the serialization of the transactions so that we're transaction two has happened, we're back to a consistent state, then transaction one happens. And we saw one of our scenarios was when something was not that transaction went through, but the transaction got rolled back. And here, transaction four, you see at the bottom of transaction four, that's going to be rolled back. So we're putting in $100 into the account and taking $10 out of the other account as before. But something went wrong with transaction four. I suggested before maybe the $100 bill was counterfeit or something. And so we're putting, so we start that transaction, we lock it, we're getting we're reading the balance, we're adding the 100, we go to write it, and then we say, no, no, no. And we roll it back, and we take that 100 back out, and then we start the transaction on the other side. And so we have not prematurely read the account with the 100 in it. No, the rollback has occurred only on the either on the commit or on the rollback are all the final locks released. And so then only after the commit or the rollback, either way, is the later transaction allowed to sort of come in and take place. And then we had another scenario of where one was just doing some analysis. We are doing some transactions on different accounts, and another transaction was just analyzing, just reading and doing some summing. Um, but if our reading got sort of interspersed with our writing, our analysis could be crap and not a proper analysis. So of not an analysis of any consistent state. So here we see transaction six actually started a little bit ahead, but it's doing some calculation. So it was initializing some variable which had nothing to do with the data. In the meantime, transaction five gets started, and it wants to move money around in some accounts, and so it puts in the locks. Then the analysis, transaction six wants to get started, but it's seen that the data it wants to analyze has the lock, and so it goes into the wait phase until all that. So this is forcing the analysis to only occur after the transaction has occurred. And it could occur the other way, that if that read of balance X in the analysis had put in the lock, then transaction five would have to wait. So either we're going to do the analysis and get it timestamped to know when the analysis was done, and then do our moving money around in the accounts, or the other way around. We're going to do all our analysis and then do our transfer, or do our transfer and then our analysis, but they're not going to mix because of the two-phase locking. Okay. If we didn't manage all this stuff, we had talked about a rollback, um, and sort of like if a transaction doesn't go through, then we have to roll back. But if we don't handle our transactions properly, and then one transaction ends up rolled back, then we might have to end up rolling back other transactions that we thought were successful, and that's the concept known as cascading rollback. So um, we want not only successful transactions not to interfere, but we don't want any uh, unsuccessful transaction to cause problems of what seem to be successful transactions. So we want to avoid the cascading rollback problem. Okay. So one of the ways to do this is to even up the ante a little bit more on our two phase and really just like not let go until the end. So, um, I do, so my shrinking phase, I don't know, I sort of shorten my shrinking phase to just like at the end, I uh, let go of the locks I have. Um, you can allow shared locks. I mean, again, so in this, another way is to again treat the shared locks and the uh, exclusive locks differently. So, if you are in your shrinking phase, you can sort of start to give up your shared locks, but hold on to your exclusive locks until the very end. So this is just adding to the rigor of the locking system to prevent any transaction problems, and whether the transaction is satisfactory and committed or unsatisfactory and rolled back to prevent all these kind of problems. Okay. Now, this is a different problem of two transactions wanting the same data. So now we have this whole locking system to prevent uh, problems of transactions interfering and leading to sort of inconsistent states. But there's a different problem of what's called deadlock. So I can have a transaction that's going to require a bunch of data, and so during its growing phase, it's requesting more and more data. And I have a second transaction that comes along, and it involves a number of pieces of data that it needs, and it begins locking. And then they encounter each other. And then transaction one wants some data locked, all that's already been locked by transaction two. And transaction two wants some data that's already been locked by transaction one. And so now neither can proceed. They're both waiting. So normally, if what we've seen before in our examples, one was forced to wait, but the other one could proceed. In deadlock, uh, by the sort of cross purposes, data requesting and locking, they're sort of both forced into the wait state. And this is known as a deadlock. And so a database has to have some way of dealing with that. So here is this example again, two transactions wanting similar data, and transaction here 17 comes along and it starts off with it needs X and Y, and it starts off with X. And so it's putting its locks on X. Transaction 18 comes along and it also needs X and Y, but its process involves Y first. And so it put its locks on Y. And so when 17 starts to want Y, it sees that it's already locked by 18. When 18 wants X, it sees it's already locked by 17. And they're both in this infinite waiting game. And so a database has to have a way to deal with that. And so um, there are different ways to do it, but again, it must be a something built into the database management system. Either they might both uh, sort of stop their transaction and sort of wait for a while before starting the transaction again, and maybe one will get done before the other one starts to hold the data. But anyway, there's got to be a process, and you don't usually have to. It's a thing that's built into the database management system. So you, as a user of a database management system, you should appreciate that that feature exists, but you're typically not uh, responsible for implementing it. It's usually like part of what you've purchased. All right, and that is the end of this one. So we saw in part one, we sort of defined the concept of transaction. In part two, we talked about the problem of isolation with concurrent transactions and how they can interfere with each other. And in this part three, we talked about a system of locking, and particularly sort of two-phase locking and rigorous two-phase locking and so on, to sort of prevent more and more the problems that could occur of transactions interfering with each other and leading to inconsistent states. And even with all the locking, there was still then the locking. This locking was the solution to a bunch of our transaction problems, but then it in turn caused a deadlock problem that then we also needed to resolve. That's it for this one. Thanks for your attention.